Okay, so we are going to look at solving equations with models. The first one we're going to look at is balance scale models. And we can use these to solve an equation by understanding the fact that we need to do the same thing to both sides in order to keep the scales balanced. So for example, in the first scale, we add 1 gram to each side. This ensures that the scale stays balanced. So then in total we have 11 grams here and 11 grams here, which means that this is equal and the balance stays. Or we can remove the same mass, so then this leaves us with 9 grams and 9 grams. So the scale remains balanced. Our first example here, Herman is in the last round of a spellathon in his school. A contestant receives 3 points for every word spelled correctly. Herman has 42 points. So how many words has he spelled correctly? Well, I have 3 little blocks over here, and I want to get 3 little blocks on this side. So 42 divided by 3 is 14. Now I'm going to remove these 2 and these 2, keep my scale balanced, but then also clearly see that Herman has spelled 14 words correctly. So then write our sentence. That was weird. Has spelled 14 words correctly. The next type of model that we will look at is algebra tiles, and in this one we're going to use our zero principle. So recall that 1 yellow unit tile represents +1. 1 red unit tile represents -1. What happens when you combine 1 red unit tile and 1 unit tile? Well, from our integers unit, it should make a lot of sense that when we have +1 and -1, we have 0, or -1 + 1, 0. So that's what this zero principle is that we're going to combine pairs like this in order to zero them out. So let's look at this. We have on our left side here 3x minus 8 is equal to -x. Okay, so we need to isolate the x tiles on the left side. We're going to add 8 yellow unit tiles to make the 0 pair. So you can see here that we have pair here, 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 and here, and here. Now from that balance scale, to keep the balance, we need to add 8 yellow ones to the other side as well. Doesn't matter that they don't have a 0 pair, because what we want to do is we want to isolate these guys. So now we need to isolate the unit tiles, so our x value. So we had a -x over here, so we added an x. So that moved this out of the way, zeroed it out. And then we had to add a yellow unit tile, x tile, to the other side as well. Now we have 4 x tiles, so we can arrange the 1 unit tiles into 4 equal groups. And we have 4 equal groups over here. So if we think of that balance scale model, if I have these by 4, get rid of these 3, I can say that x equals 2. And I can even check that. Our original equation was 3x minus 8 is equal to, sorry, not -2, is equal to -x, right? So then 3 bracket 2 minus 8 is equal to negative bracket 2. And then you get 6 minus 8 is equal to -2. So -2 is equal to -2, which means we did it correctly. Okay, and then you have your practice questions on the following page. Let me know if you need any help. So I forgot that we had an example here, so let's do the example together. Jody is a contestant in a spellathon. A contestant receives 3 points for every word spelled correctly. Because of a technical penalty, Jody loses 5 points. She now has 19 points. How many words has Jody spelled correctly? Well, if we think about this, so she receives 3 points for every word spelled correctly, but she lost 5 points, and she now has 19. So using algebra tiles, how many words has Jody spelled correctly? Well, let's get 3 of these guys. So 1, 2, 3, 5 of these. Oops. And 19 of these yellow ones. So the first thing that I need to do is I need to move and zero out these red ones, okay? So what we're going to do is we are going to add 5 of these guys to create, oh, I noticed that there's only 4 there. 5 of these. Let's get that there. So then these guys zero out. And then let's copy these over. And they come over here. So then we can get rid of these guys. Him too. And we have 3 of these. And we have 24 of these. So we need to arrange these into 3 equal groups. So I know I have there, and there. So that's 1, 2, 3, 4, 5. Let's take 1 each at a time until it lines up. And if we count these up, we can see that we would have that J is equal to 8. A little bit more of a longer process, but definitely worth in order to see how it works. Let's go down to the second example here. So use algebra tiles to solve 8 is equal to -6 minus 2x. I'm going to pause the video here and get my equation set up. Okay, so now we can see that we have 8 is equal to -6 minus 2x. The first thing that we'll do is we will create some 0 pairs. So I'm going to do some 0 pairs for -6. Now that we have the 0 pairs for -6, we need to make sure that we do it to both sides. So we add them over here. Let me kind of line that up a little better. Which means that we can now get rid of these guys. And then we have -2x's. Now, I don't like the -2x's, but we can deal with them because we have that integer knowledge. There are 2 different ways you could go about this. You could add these 2 and then have these 2 over here. And then what you would do is you would turn all of these guys into negatives and then move them over to this side. And then you would have these guys over here. And then we remember, because we moved these guys over to the other side of the equation, that we had to subtract them to get rid of them. So now we have 2 of these, and we need to kind of organize them into equal groups. So let's do 4 up here, and then we'll do 4 on the bottom side, and we'll do another 2 up here, another 2 down here, and 1 and 1. So then we can see that we would have x is equal to -7. Count those up. And we'll check. So then we go 8 is equal to -6 minus 2x. 8 is equal to -6 minus, sorry, -2. I'm going to rewrite that. -6 minus 2 multiplied by -7. 8 is equal to -6 minus plus 14. So then 8 is equal to 8. Good. All right, now you can go on to the assignment on the next page.